Okay. See, generally when we are actually writing the program, we'll come across many errors and all. Okay, already మీరు program చేస్తున్నప్పుడు you may have observed that you were getting some errors when you are doing some mistakes. Like ఒక ఆబ్జెక్ట్ వాల్యూ ఇవ్వకుండా దాంట్లో మెథడ్ యాక్సెస్ చేయడం ట్రై చేయడము ఇలాంటివి చేస్తున్నప్పుడు you might have already observed some issues actually.
Okay.
Those kinds of issues are something that we can handle by using if else while. Say, for example, you may be trying to write a specific content into a file. Okay. And what if the file that you're trying to write to is not there on the hard disk? What should happen? You can handle that in such a way that whenever you're trying to write, you can verify if that file is there, only write if that file is there, or display some error message. So that is one way of handling. But writing this way will actually be longer. So will actually be getting tedious because there may be hundreds of lines you are writing, and for every line you will have to check what should happen, what should not happen, etc. Instead, exceptions provide us a simpler way of handling those kind of errors or exceptional cases.
Okay.
So, whenever when we are actually running the program, you assume that you try to write the code in such a way that you assume no exception occurs or no error condition occurs, and you proceed. Okay? And while you are writing the code, you will assume that it's not going to throw any error or no error condition exists. Okay? But whenever there is an error condition, whenever an error condition error condition has occurred, what happens is the runtime, Java runtime, whatever is running the program, that will be creating an object as to what that error is, where that error has occurred, etc., and it will be passing that back to the runtime. Okay, so and runtime will try to see if there is something, whether you are handling that error in your code or whether you are simply uh, throwing back that error to the previous caller or something like that. So whenever we actually whenever our program emits that kind of errors, unless you handle that, what happens is it will be propagating to the callers, previous callers, and ultimately, if you haven't called anywhere, you haven't handled it anywhere, that will simply be throwing an exception and quitting the program. You have actually what actually happens is, say for example, our runtime will be invoking the main method, and that main method will be executing that code. When all the lines of code is executed, the control will be passed back to the runtime. Whatever process that is actually running our program, it will be getting the control. In case there is some error code which you have not handled, so what happens is, at that error code, it will simply be quitting the program, and the control will be passed back to the runtime. Runtime will try to see if you are actually handling that error, or whether you are actually simply not handling that error. So if you are handling that error, it will be simply executing the subsequent lines of code. Otherwise, it will be quitting the program. Imagine you are actually calling a method in your main method, and that method is actually causing some exception or some error condition. What actually at that time, when that method has actually created that error, causes that exception, runtime will try to find out if that method is trying to handle that exception. Okay, if we are not handling that exception over there, that exception will be passed back to the main method, and see if you are actually handling that exception in your main method. If you are handling it, it will simply be executing the subsequent lines of code in the main method. Otherwise, it will simply be quitting. So that way, it will be propagating all the exception, and it will store the information as to what is the stack trace. So how did we come here? Which method is calling the which method has called the method, called this method. Subsequently, it will be storing all that information. It will be simply throwing that exception. Okay. So, in our uh, actually, whenever you have been programming and all, you may have actually observed some error conditions. Can you think of any error conditions that may have come?
Buddha, actually, whenever we code, since we compile the code,
Mhm.
or maybe since the code is not that much complex, we did not get any error message, exception error message as such.
No, forget about the exception error messages. You may
Okay.
have written a lot of things so far. Okay. Do you think there are any cases where uh, you had a chance of getting an error or something like that? Imagine you have an array. Okay.
Okay.
And array is of 10 elements.
Right, right.
Okay. And what happens when you have actually tried to access 11th element?
Yeah, out of bound error. We got that error. I got that error.
Right. So those
Right.
are all kind of exceptions that you may have already encountered. Okay. And can you think of any other things? Uh, Imagine
No.
you have a
Mhm.
method in a class, okay,
Okay.
which is not static, and
Mhm.
uh, you have not created any object of that class, and you try to access that object. What happens? Have you ever had that kind of issue?
No.
If you had, see, what happens is in real world, the programs are not this simple. The programs are very big and very complicated. So people tend to make mistakes. So in that case, you may write some piece of code and the other person may write some other piece of code. What happens at that particular point of time is you will be getting something called as null pointer exception. Do you remember seeing any exception like null pointer exception?
No. 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 Buddha.
Okay. So if you had, that is one such exception. Okay. And there can be many such cases. Like, say, for example, there is I told you that we can do something like casting, right? By putting a data type in brackets, we will be able to convert a specific data to numbers, or even we can use parse method to actually convert a uh, specific what is that some text value into a number. So that kind of things, if we are trying to convert abc into a number, what happens is it will simply be throwing an exception. Okay, so those are all different kinds of errors that may happen. Okay? So let me just
Okay.
show you a small things before I actually go in there. So far, we have always been using numbers, text names, only those things, right? Now, let us see some things on how we actually handle dates.
Okay. Can you please share your screen, Buddha?
Yeah. Oh, so far I haven't been sharing the screen. Okay. Okay, these are all the slides I covered. I was under impression that I have been sharing the screen.
Okay. Okay. I thought that you are just giving some. Okay. Fine. I will take a look later.
Okay. Let me. Okay. So the date, so far as I've been telling, I've been only explaining, we are only simply using numbers, names, and only the or booleans. Okay? So far I have not explained you how we can handle the dates and times, etc. Right? How do you write a program that is actually maintaining the accounts of multiple organizations. Okay, they will have to use when they have used a specific date, and when they have actually got a specific order, how much money uh, they got, etc., along with the dates. So to actually manage dates, the old Java program actually has given us the a class called as date. And now when we actually print the date, whenever we create a date object and when we print that object, what we get is, okay, now if you see, whenever we create a date object, we'll be getting the date, the time at which we have created that particular object. Now if you see, it is 6:56:04 now on November 9th, and if we run it again, it is 6:56:19. So this way we can actually create a date object and use it to actually store that actual timestamp. So now if you have, we have a lot of methods on this, and get time will be converting that particular the current timestamp into number of milliseconds since the 1970 January 1st. Okay. And 1970 January 1st is something called as epoch time, because all these programming language, most of these programming language, they have started being developed after 1970 or so. They started counting most of these things since 1970. So this get time will give us number of milliseconds that has passed since that particular time. Okay, that is called as epoch. Now, if you see, we have a lot of other methods, whether to test a specific date is before that or not. Say, for example, we have two dates. This is first. Now, when we run this program, we may get same kind of thing here, because the program runs so fast that the number of seconds may not change between this line of code and this line of code. So let us actually try to print the number of milliseconds. Even the program may be even executed even before that single millisecond has passed, but let's try. Oh, yeah, they happened in the same millisecond also. So let us sleep for some time so that we will be okay. Now thread.sleep is something that we can use to actually make this program sleep for some time. Okay, without instead of actually executing the program immediately after executing this line number 12 immediately after this line number 10, we can use this red dot sleep, so that this will be waiting. So this will be throwing something called as exception. Let us just put it, select this first option, and let's not worry about this. When I explain the about this exceptions, you will be understanding it better. Now let us run the program. Now if you see, at 5:57, we executed this line and we waited for 100 seconds, sorry, 100 milliseconds, and then we created another data object. So we got a number of milliseconds as this. This way we can actually create a data object. But what if we want to create a data object of a specific time? We can do that by date new date. We can pass that year, month, and date in this methods. Okay, but there are some small problems with this. Okay, if we want to use this, we have to remember some specific things. Okay, that is, if you see this, this is called a Java doc. If you read, you will be able to understand what this method does. And now if you see, there are multiple constructors for this. One is we can give a number of milliseconds since 1970, or we can give year, month, date, or we can give year, month, date, and hours, minutes, seconds, and all. So now let's concentrate on this method. If you want to create a date of, say for example, our date of birth, okay, let's say April 1st, 1986, and if you want to give year, you have to give year, the year, and year minus 1900. So you will have to give 86. Okay, and also what other thing is there? And months, we have to give zero based month indexes, like we have to give 0 to 11. So if we want to give January, we have to give 0, whereas if we want to give December, we have to give 11. So April means 3 then, and the dates are as usual, so 1. So now what this data object represents is, this will be creating a data object at 1986 April 1st. Okay, so now if you see, you may think that this is confusing. Yes, this is confusing. That's why they have actually deprecated that particular class, the constructor, saying that okay, don't use this, there are better things to use. Okay, if we come to later versions of Java, if we had this, date is initially started in Java 1.2 version. Now we are actually on Java 1.8. So we are no longer actually going to use this constructor. Instead, we will be using something else. I'm going to tell. Now, if you see, the specific time is this. Now, as I was telling, the date class has many methods that we can use. This will be comparing another date, and it will be returning an integer like the number of. It will be returning whether the date is before or after, etc. Okay, and the other date is before or after, and we can also set some specific time, and date will be returning true or false whether the, if we say for example, if we give after, and say for example if we give first, if we print it, we'll be getting false, because specific time dot after first is false. Okay, first is specific time is not after first. So that's what this particular, so we'll be getting false. This way we can actually do lot of handling of dates and all. Okay, as I was telling, uh, we have actually got a better things. Okay, that in the later phases, the date class is still there, but to create a date instance, you don't actually be creating a using a date constructors. Instead, you will be using calendar classes. Okay, calendar dot Gregorian calendar dot. Now, if we create a get instance, if we call this get instance method on this calendar object, if you remember, we have gone through something called as singleton. This is calendar.instance is nothing but a singleton. So now the other way of creating date is by using the calendar.get instance. Now we can pass a specific date, or you can even pass a specific year, month, etc. Thereby we can mention the what time do we want in this particular calendar object, etc. If we want to handle those things. Alternatively, we can also use the other constructor that actually take the along with the hours, etc., instead of passing the date object. Okay, so either way we can actually create here. If you see that the Java doc for this method, it will say that year we have to pass the year, like if it is 1986 we have to pass 1986, but this also has a small confusion of using zero based index. So if we want to give December, we have to pass the 11 to actually create set a time for this. Okay, imagine you are taking the okay, before I go there, let me explain you something else as well. Imagine you are actually taking a date from the command line. Okay, so you have written an object scanner. Now, if you see s dot s can actually read uh, next line. If you see, it is returning bytes, doubles, floats, and integers, longs and shorts. All it is reading. But if you see, how do you actually make sure that you ask the user to give a date, or how do you convert a date that which can be used to actually uh, read a date from a user? Can you think of something that we can use?
Uh, Character string.
Yes. The it is We can actually use string, but the string we cannot directly use it in our program like a date. Okay, if it is a string, what we will not be able to use that string as a directly as a date, like we cannot use after or something like that. Okay, so what we actually do is we read it as a string, but later on we have to convert that string into a date, or in simple in programming language term, we have to parse the string into a date. Okay, so to do that, what we actually use a class called as simple date format. Simple date format. And this actually takes input as a pattern. Okay, see a date, if you give in US the date format will be YYYYMMDD. If you go to UK, the date format will be something else. Okay, if you go to India, the date format will be something else. So there is no single way of restricting users to use only specific format of date. Each country may write it differently, right? So what the programmers have done is, instead of hard coding any specific format, they have asked you to provide the format when you actually do. So now if I give YYYY, that will be 4 years. Okay, and then capital M means month, and DD means small year. Okay, and if I give these slashes, now what I have mentioned is I'm taking the format of the date for my program is YYYY hyphen MM hyphen DD. So now we can use this parse method. wherein we
Okay.
can. Did you say something? Are you saying something?
No, I just said okay.
Okay. So we can actually use this s dot next. The if we read whatever we read from a user, we can directly pass it back to the parse method. Therein it will be returning a date object. For now, let me just say add throws. I'll explain you what this is in next 5 to 10 minutes. So now what it will be doing is date d equals to. Now if we run the program, it will be waiting for us to enter the date. Okay. Now let me enter 1986 hyphen April 1st. Now, if you see, it has converted my string to a date object. Now we can perform all kinds of operations on this date, get time, blah blah blah. So whatever you want, you can do. So what we have done over here is we did something called as parsing. We have parsed the string, whatever the user has given, and that means we parsing simply means understanding. Okay, so this string has been understood as a date, and because we have actually given it mentioned in this format, and the user has also given the same format, the program has is able to successfully execute. Now imagine, okay, before I go to exceptions, let me cover one small thing. In Java 8, they have actually introduced, so as I said, calendar is a new way of actually creating objects, datetime objects and all. Calendar is a later, calendar has many more other utilities that we can actually use to that we can use to actually operate on dates and times. Okay. However, as I said, this also has some problems. So it doesn't handle time zones and all very well. Programmer has to take care of all the issues with time zones, etc. So what they've done is they've introduced new API for handling date times. Okay, in that new API, they have actually introduced many classes. So they are introduced in new package called as java.time. If you see the date here, that is actually is there in java.util package. Same is the case with calendar, and simple date format is in text package, and Gregorian calendar is also in util package. Now for dates and times, they have created a new package called java.time. In that, they have created a lot of classes like instant, local date time, local time, and these are all times that actually do it without actually considering any time zone at all. If we want to use time zone, we have to use this zone date and time. Okay, so this way we can actually mention which time zone a specific time belongs to, etc etc. So if you want to use this classes, we can simply use them. Now here, to create objects of this, we can actually create by calling now method. Now method will create a local datetime object at this particular point of time, or we can actually use this auth method to give the years, months, and dates to actually create those objects. Now if we want to create this, here 90, okay, with this new API, they have removed all the confusions. Okay, you don't give zero based index for months or anything. So if you it is April, you have to give 4, and everything else is same. Say 12, 31. Now if you see, it has created this 1986 041 T1231. So this way we will be able to create a specific sorry, use the times in the latest API. Okay, what is the advantage of the latest API? Is there won't be any confusion that they have many other useful methods that we can actually make use of, to that will be helping us to do all these things very easily. and also there is no confusion in terms of using time zones and all. If we want to use time zones, we will be simply using that zone date time. Okay. Now, if you see off, we can actually give a specific zone ID. We will have to know what is the zone ID that we want to use, etc. Mostly, they will be available in the internet if we search. So defaults will be UTC will be the default time zone. Okay, so this way we can actually use time zones in our program. If you want to write a program that actually handles time zones and all properly, with this new API, it is possible. So all those required classes are available in our Java.time package. So I want you to take a look at them. If you are actually going for a certification for Java 8, they may have some questions on this new classes that they have created. Okay, so that is also
Okay.
important. And now, as you said, now let's come back to our hero topic for this session, that is exceptions. Now, what happens if we have written the program like this, right? Now it is waiting for us to enter a date. What happens if we don't give the date in this format? What happens if we give, say, for example, 1986, or in place of month, what if we give something like 89 and then say 01? Now what happened over here is it simply rolled over the dates. Okay. Now if you see, it simply rolled the dates. Now so the formatter is actually doing that job. Okay. If we give more months, it will be simply rolling. Now what if we give it in a different format? What if we give 1986 and April, and we don't give the date point? What actually happens? Can you guess?
So DT will be spaces, and then yeah, yeah, it might throw error.
It will be throwing an exception. That's the correct word of correct
Okay.
word to use. Okay, because it cannot
Okay.
understand. And can you tell me which exception it will throw?
Invalid date.
No, actually, if you had observed the program that we have written, you may have observed that we have used something called as uh, in line number 14. If you had observed clearly, okay, we have something called as throws parse exception. Do you see in line number 14?
Yes, Muthu, I can see that.
Okay, so
With
now this is an exception that will be thrown when something doesn't go correctly. Okay, so now when I press
okay.
enter, what I get is in my Java in my it is because it's JUnit, it will be simply be displaying an error message like this. Instead, if it is, say, for example, a main method. Okay, now what happens is it will be throwing an exception 1986. Now, if you see, it says exception in thread main java.text.parse exception imparsable date 1986. Okay. So now, if you see, it has given us more information as to what is this, what kind of error has occurred. So this is called as exception. So this exception has given us the message as to what is that error condition that has occurred and where it has occurred. It has occurred in date format dot parse method. Okay, where is this? We have not called this method, but we have called this method in our line number 28. Okay, in here we have called formatter dot parse, that actually taken us to the datetime for date format dot parse method, because that formatter dot parse is calling that particular method. Now, if you see in line number 28, this is where that exception has occurred. So while parsing that object, we have got this exception, which resulted in this specific exception. Okay. Now, there are these are typically called as exceptions. Okay. And if you see, we haven't done anything. The program has quit suddenly. Okay. Now, what if that's not what we want? What if we want to handle it somehow so that our next lines of code gets executed subsequently properly? What if we want to ask the user to give the date again? Okay, so if we want to do that kind of things, okay, we may be thinking until we actually get this date, we want to ask the user to do. So to do that, what we actually have to do is we have to handle this exception here. We have to catch this exception. What we are doing over here is we are throwing the exception. Okay, that means we are simply throwing the ball back to the runtime to handle it in whatever way it wants to do. One way that it is handling this, it will be simply printing that error message in the console and exiting from the program. Now, what is the other way? The other way is for us to catch the exception and make sure that we do necessary cleanup operations, or if we want, ask the user to provide the date one more time, etc. So all that things we will be able to do by using something called as catch. Okay. So to actually to how what do we do with these exceptions? There are two ways in which we can actually proceed whenever an error occurs. One is actually catch, not when the exception occurs, but when we are programming. One is when we actually get we assume, we try to find out, or we try to imagine what kind of exceptions may occur, and we try to catch them. Or whatever method we are writing, we have to specify that we are going to throw this exception. Now, if you remember this particular piece of code, can you tell me what actually we have done? Can you guess what we have done here? As I said, we
We
have two
accepted a
ways.
date from input. Yes,
Okay. Now,
we
what
accepted
did we do
date
with
from
that
input.
exception? What did we do with that exception? There are two ways in which we can handle them. One is catch them and do something about it, or simply specify that we are going to throw this exception. What exactly did we use? What did we use in this particular piece of code?
We did not handle the exception. We just used the throws, interpret exception, and pass exception.
Yeah. Uh, so, what do you think it is like? Out of those two methods, what exactly is that?
Interpret exception.
No, no. This is one type of exception that will be thrown by this. Okay. What my question
Okay,
is, are we catching it, or are we specifying it?
we are specifying it. We are not catching it.
Right. Okay. So we are simply telling that our main method is going to throw this exception. That's why. So until we tell this, our program is actually giving us an error. Okay. So we have to either handle it by catching it or by specifying it. Okay. We have simply used throws exception, throws keyword to specify that our main method is going to throw this exception. Okay. Let's say I have a method called printer, and here now, instead of that formatting thing, instead of that happening in our main method, now I moved that code to printer method. Okay. Now what actually is it is telling? It is telling that we have not handled this parse exception. Okay, which means either we have to use something that I told just now, that is either catching it or whether throwing it. If we say throws exception, okay, now what actually has happened here is my printer method is throwing the parse exception. Now if you see, because my printer is throwing the catch exception, and we have to somehow handle it in our main method, because main method is the one that is calling the printer method. Okay, so if printer is not handling the specific exception that has been thrown by it, main method is responsible to handle that. Okay, so here also we can decide, choose to actually throw this exception. That way that exception will be passed back to the control. Now if you see, if you remember what happened over here, when this exception has occurred, it did not actually print any date and time here. Okay, that means any lines of code that are after the exception will not be executed if we simply throw the exception. Okay, now if we run this program, if we give ABC, now if you see, it says unparsable date. Now observe the stack trace clearly. Now that exception has occurred in date format class in parse method, and line number 366. Okay, because that code does not belong to us, we will simply be not be worrying about that piece of code. Now if you see this datetime demo dot printer, this is the name of the class and this is the name of the method. In printer method of datetime demo class, in line number 34 we got this particular exception. Now this is where we got this exception, but how did we call this method? Where did we come to this method from? We called this method in line number 27 in main method. Now if you see, now if you remember, main method and main method has called printer method in 27, and printer method has called date format dot parse method in line number 34, and simple date format or dot parse method has called date format or method in date format method, and that's where we got this exception. Now this is called as stack trace. Okay, as I was telling you, each method where that particular method has been triggered, and all that kind of information will be stored by this exception, and it will be handled by the runtime if we are not handling it. Okay, now because our printer method is throwing this exception, that either has to be handled in our main method, or our main method also has to be throwing it back to the runtime. Now let us see what is this catching thing. Okay, as we have seen specifying, that is simply mentioning that throw using throws keyword. Now let's see what is catch. Now the typical syntax of catch will be something like this. We try to execute some code, okay, which we will be enclosing it in a try block, which will be starting with the keyword try, and all the code that has to be the part of the try block has to be in that parent in that braces of the try. And whenever there is some exception occurs, we will be writing a catch clause where we mention the exception that we want to catch, and then perform some cleanup operations. Okay. Now this is a typical syntax of try catch block. By using this, we will be able to write the handle the exception in a more graceful manner than the simply printing the error and quitting the program. Okay, and now whenever we do something like this, if an exception occurs in try block, that exception will be caught and the cleanup code will be executed, and then the rest of the code after the catch block will also be executed. Okay, now we can also have multiple exceptions from the same piece of code, as you have seen in this code. We have multiple exceptions in this particular in this piece of code. One is this ted.sleep may cause an exception, or this printer method may cause an exception. So each are throwing a different exception. So those exceptions can be caught separately, and a separate cleanup code can be executed for each of the exceptions. Okay, so we whatever whenever this kind of thing happens, it will be going from top to bottom. Whatever catch clause satisfies that exception for the first time will be used to execute that piece of code. Okay, so if there is, say for example, if there is one exception, and if there are two exceptions that can be representing the same kind of issue, and whatever first exception that will be matching to that exception thrown will be executed, and the rest of the code will not be executed. Okay, I'll give you that demonstration just now in a moment actually.
Okay.
Okay, so now, if you see, this code may execute some, say for example, print some things. Okay. Now we have some code now exiting. Okay. Now we want to make sure that we execute this particular piece of code before we actually exit the program. Now, if we run the program, there is no guarantee that that is going to execute. If the user has given a wrong date, it is simply throwing an exception and it is not going to execute that particular now exiting line. Now, what do we do? How do we do that? If we want to execute this one, we have to catch this exception and do some handling over here. So now to do that, what it I say, we can use this try keyword and enclose whatever code that we want to try in this try block, and then we have to mention the catch, and we have to use whatever exception is going to be thrown. Parse exception, say e. Okay, now what actually happens is when this exception has occurs, because we have written a catch clause here, that exception will be caught here. Okay, and whatever piece of code that we execute here will be sorry you write here will be executed. Now let's say we want to ask the user to execute it again. I mean, give the date again. Sorry, date is valid. Now, what we have done over here is we have caught the exception, but again, because again we are calling this method, we again have chance of creating getting an exception here also. So we will have to catch this or throw this again. Okay. So for now, let's not go to that kind of looping problem. Let's simply say that sorry, date is invalid and exit the program. Okay. Now, if you see, what we are doing over here is we are catching the exception, so we don't have to throw it back. Okay, that means the runtime sees that there is a catch block here, so it will not be quitting the program. Instead, it will be performing whatever operations we have written in this block of code, and will be simply running the rest of the code also. Now if we run the program, now, if you see, instead of throwing that exception or printing that error message, it simply printed that sorry, date is invalid, and then it executed this program also. Now, if you see, we are able to write this code without actually throwing it back. Okay, you may see that okay, what exactly did we gain over here? What we gained over here is we are not quitting from the program. Okay, so the main benefit you see is this: we can have code that actually encloses multiple kinds of exception, and each kind of exception may have to be. Now imagine we kept this particular piece of code also in the try block, and now we don't have to throw this, provided that we catch that particular exception also. Okay, now if you say catch and interrupt exception, what we will be getting is interrupted. However, we cannot reproduce this thread dot this particular sorry interrupted method because there is no way for us to actually interrupt program sleep, especially in single threaded application. You will understand what is threaded application at later point of time. But the point of this is this. Now, let's say we are actually trying to create an object, or say, for example, there is a static method. Imagine there is a public Okay, let us create an object of date itself, date null object. And now we are not using any constructor, that means we are not creating any object. What happens if we simply call null object dot say get time? Yeah, okay, because some value has to be kept, let's put null here. Now what happens over here? Now this is going to throw something called as null pointer exception. Okay, now if I run this program, I got something called as null pointer exception. Now, if you see, because earlier when our code had a chance of throwing some exception, we had to either catch it or throw it back in the main method. But here we did not have to. What that is, I will come back to that. These are called as runtime exception. I will come back to that in a moment. However, what you can understand is if we can actually write now when this null point exception has occurred again, the subsequent lines of code did not get executed. If we want to make sure that this now exiting gets executed compulsorily, we have to write a catch block here and catch a null pointer exception. And we can actually call a method called as print stack trace, which will be simply printing a stack trace like this. Okay, and then it will be executing this other piece of code. Now let's execute this code and see what happens. Now if you see, it has printed the stack trace java long null pointer exception at demo main, and then it has printed now exiting. Okay, it has printed in some bad order because the Eclipse console has that buffering issues. If we execute this program outside, they'll be executed properly only. Okay, so don't worry about this lines mix up and all. So now if you see, this printed this print stack trace and then it printed now exiting. Now what happened over here is we are catching multiple exceptions over here. Okay, now I said if whatever exception matches that first will be used to actually catch this, right? What do I mean by how can a parse exception handle null pointer exception? It really cannot. What do I mean by other exceptions also being able to handle is this null pointer exception is a class which is actually extending from some class called as runtime exception. Okay, so now instead of null pointer exception, I can also give something called as runtime exception here. Okay, and if I go to this runtime exception, this is actually coming from exception here. Now instead of the runtime exception, I can also give exception. So now parent class can, as I said in the previous sessions of inheritance in composition, parent class can be used to actually store or refer or point to the child objects. Okay, child objects. So we will be able to catch any exception if the exceptions if we use the parent class. Now interrupted exception, now if we come to this interrupted exception, that is actually directly coming from something called as exception class. Now if we give an exception here, now what it says is because we are catching the exception here, the subsequent lines of code will not be executed because null pointer exception or interrupt exception, everything is are ultimately getting coming from this exception class only. So what we will not be able to do is we cannot give a parent class at the top, otherwise no exceptions will be caught. So it says that okay, this particular piece of code will not be executed because we are already handling that particular exception by catching the parent class exception. Okay, so we always have to give the child classes at the top, and then if those exceptions are not handled, then we will have to handle the larger exception. Now, we may get an exception that doesn't belong to any of these three exceptions. In those case, what we can do is we can actually catch the exception, and here we can print. And this way, what happens is if none of these three exceptions occurs, but some other exception occurs, then what happens is this particular block of code will be executed. Okay, so now if we run this program, because null pointer exception is going to happen first itself, and no other things will be executed. Okay, now if we execute this program, now if you see null pointer exception, and then after that, now exiting. Okay, this way we can actually catch the exceptions, and if we don't catch the specific exception, it will, our code will be throwing an exception saying that, okay, boss, you have to handle this for that specific exception, because exception is also handling the this parse exception. Exception is the mother of all the exceptions. So because we have given exception here, the parse exception is also indirectly handled. Okay, now if we say, if we don't execute these two lines of code, now, if you see, some unhandled exception is printed. Okay, now exited. This way, whatever exceptions we handle will be handled by that specific exceptions. Otherwise, if we mention a catch clause with a mother exception, that is called exception class, and that piece of code, that block of code will be executed, so that we will be able to handle all the exceptions, because we cannot anticipate there may be underlines of code. We cannot anticipate all kinds of errors that may come. So in that case, we will be simply catching the exception to make sure that we clean up, to make sure that we uh, close or do some cleanup operations, or perform some graceful cleanup operations. Okay, so this way we will be able to catch the exceptions. Okay, now, if you had seen the code earlier, for my date, for simple date format dot parse method, unless I have either got the exception or mentioned the throws, it did not allow me to use that line of code or compile the code. Right? Those kind of exception are called as checked exceptions. Okay, these cannot be ignored at the time of compilation. Okay, we have to make sure that we handle these exceptions. Okay, and that's why these are also called as compile time exceptions. And there are other type of exceptions. So those kind of exceptions are something like programmer mistakes. Okay, simple errors that can be fixed by proper coding. Now, like say for example, null pointer exception. Now if you remember the null pointer exception, it's a mistake we have done. Okay, we know that this particular issue is coming, so these are actually bugs in the code. So at that time, what actually happens is we don't have to make sure that we either throw or we catch that exception. Say this null pointer exception, we don't really have to throw that. Okay, let's say printer, let's throw this. Now here we are only catching the interrupted exception. Now we are not uncommenting this, so we are not catching this null pointer exception. Now still we have not got any error, right? Instead, if we had not given this parse exception, it will my printer line will method call will be throwing an error. Why? Because this parse exception is a compile time exception. Okay, or checked exception. Our program will not compile unless we fix that error. Alternatively, this null pointer exception is not a compile time exception. These are called as runtime exceptions. Okay, they will only occur at the time of running. So it is not mandatory to throw or safer or catch those exceptions, but it is always a good thing if you handle those exceptions. So these are not that serious errors. That's why these are not checked. Okay, so what do I mean by checked and unchecked? The checked and unchecked means, checked means they are checked by the compiler itself, and unchecked means they are not checked by the compiler. But at the time of executing the program, some because of some uncondition, some condition, uh, that kind of exceptions may occur, and those are called as unchecked exceptions. And there are other kinds of exceptions. There are errors. Okay, these are very big problems. Okay? And like say for example, the computer has run out of the memory, and it cannot run the program anymore. At that time, you cannot catch, because uh, to create this particular exception object, you need some memory, and now the memory is over. Okay, now in that case, those kinds of situations are called as errors. Okay, so you cannot recover from those situations. You simply exit the program. The runtime will simply be exiting the program. Okay, so our program will not mandate to catch or throw these kinds of exceptions. They are done automatically. And now, as I've indicated earlier, every class is coming from a class called as object class, okay, which is in java.lang package. And now there is a class called as throwable, which is mother of two kinds of things. One is errors and the other one is exceptions. Again, the exceptions can be checked exceptions or runtime exceptions. If you see this class hierarchy, you will see that the throwable class is actually extending from java.lang.object, and then the throwable class is being extended by two classes. One is errors and the one is java.lang.exception. Okay, and errors cannot be handled. Some kind of errors are illegal access error or out of memory error, and those cannot be handled at all. Okay, there is no other way except for exiting the program. And in the exceptions, all the exceptions that are actually directly extending the exception class are checked exceptions. Okay, you will have to mention either throws or use a catch clause. The other kinds of classes are actually there is a class called as runtime exception, which is extending the exception class, and all the other runtime exceptions are actually extending from this runtime exception class. Okay? These classes that are extending from the runtime exception class need not be handled. Okay, they will be handled by the runtime without you having to worry about it. But again, as I said, it is always a good thing if you handle that yourself. Otherwise, the program will be quitting. Okay, so it depends upon your requirement. If the user has given a wrong date, if you don't want to ask the user to give the date again, instead if you simply want to quit, okay, you simply throw that exception. Or if you want to make sure that you ask the user again to give a date, you will be catching it and you will be handling it. Okay, so that is how you will be uh, executing your piece of code, writing your piece of code. Now, based on your knowledge of whatever that we have explained so far, can you tell me whether array out of bounds exception? So when we actually try to access an element that is beyond an array size, that will be returning an array index out of bound exception. Okay. So now, is that exception a checked exception or a runtime exception, Srinivas? Srinivas, can you hear me?
Yeah, yeah.
So is array index out of bound exception a checked exception or a runtime exception?
It's a runtime exception
Why?
because while running the ex executing the program, it is throwing the exception.
Yes, it is not giving any error when we are actually writing that when we are actually using that at the time of compile time. Okay, so that's okay. What about the
Right, right.
arithmetic exception? Like say for example division by 0 or square root of -1. So are those runtime exceptions? Can you try that once, or can you guess based on whatever your experience is?
It's a checked exception
Why do you think so?
because while writing the code itself, we can see compiler will not allow us, will show us that it's a error.
Will it? Come on, give it a quick try.
Yeah, I will try it. I define one float and I try to divide it by 0. It's
Mhm.
saying that cannot convert. Okay, let's see that. Oh, Buddha, I wrote one arithmetic expression divided by
Mhm.
0.
Okay.
It did not show any error.
At
It just
compile time.
passed that point.
Okay. So when you run the program, then you will be getting it. Okay. So it will be evident. It is evident that arithmetic exceptions are also runtime exceptions. Okay. So checked exceptions are some things like you will see more of the checked exceptions when we try to handle files and all. Okay.
Okay.
So now, what is a stack trace? Okay, when we use the method called as e.print stack trace, it has printed the sequence of operations that took place to come to this point of error. Okay, so if there is a method that has called another method and which has thrown that exception, at what line of that first method is called calling the second method. So all these kinds of things we are actually be able to will be able to test see by printing the stack trace. Okay? Many times, whenever you're debugging some logs or when you're being developer, analyzing the stack trace to understand the problem will become a very critical point of your very critical of your what should I say like debugging. Okay, so whenever some problem occurs, most of the times all you are going to have is this exception. So you will have to understand the stack trace and try to guess what the code is. Otherwise, you it's like checking for a needle in a haystack. Okay? So when exceptions, you see the exception and understand it. Most of the times, you will be directly able to tell what the issue is. Okay, if you see the SARA index autobound exception 11, you clearly understand that okay, I'm trying to access 11th object, which is not there at all. Okay, so that way you will be able to understand it. So try to always read the exceptions. That will give you a lot of information. And then, if we all these examples that I've already explained you, the other way of handling it is throwing it. Okay, so whenever we catch an exception, we are not going to throw it back. Okay, but instead we can also manually throw it if we want. So all these things are work when you're throwing, and there is some concept called as rethrowing. What if, say for example, you don't want to simply print invalid date, you also want to print this exception and quit the program here itself. In that case, what we can actually do is we can rethrow the exception. Thereby, for example, let us catch this exception. Now, this is called as rethrowing. Okay, what we have done is here so far what we have been doing, we are catching that exception and gracefully, is my screen showing? Yeah. Gracefully
Yes.
exiting. Okay, but here what we are actually going to do is we are purposefully throwing that exception ourselves. Okay, after say after performing some cleanup operations, you don't want to execute subsequent lines of code. Maybe because user has given a file name which is not there at all for you to process. So you will be simply showing that okay, that file does not exist and it will be simply want to execute or exit. So one way is simply throw without catching it, or other ways you want to perform some other operations before exiting. So in that case, what you will do, you will simply be catching that exception and performing all the cleanup operations that you want, and then you will be throwing that exception back to the runtime. So now what happens is, so this gets executed, this because we are throwing the exception again, our program will be exiting without actually executing this. Now if we run this program, now if you see, we got sorry exception, and then we got arithmetic exception. Okay, now because we are throwing that exception, we simply got that, we simply did not get this line executed. Okay, so sometimes we may want to do this for some purposes. Okay, so this is also possible. Either we can simply ignore, or if we comment out this line, we'll be executing that piece of code. Now if you see sorry exception now exiting, instead if we throw that exception back, this now exiting will not be printed, because whenever an exception is thrown, that will be simply be handled by the runtime, because we are not catching it. Okay, if an exception occurs in the catch block, that will be simply considered as a normal exception only. If you want to catch the exception here also, we have to use a try block in the catch. Okay, so that way, again try. So if we want to do it, we have to do it like this. Most of the times we don't try to put like this, but sometimes we may have to. But that's some very rare scenarios only. You will have to do that kind of thing. Okay. So either when you throw, when you catch an exception, you will be able to rethrow it also. Okay. So sometimes we may want to do it to ensure that we have performed the necessary cleanup operations. Now we want to exit. In those kinds of cases, we will be rethrowing an exception. Now there is something called as finally block when we are actually reading this, try learning about these exceptions. Okay. Now when some, say for example, there is some cleanup options that has to be performed irrespective of whether we have actually got an exception or whether we have not got an exception. So that piece of code we have to keep in finally block. Okay, let's say we have opened a scanner object in the try block in line number 2, if you see the code, and now we want to close it. Okay, if we close it in line number, say after line number 5, before we catch any exceptions, what we are actually going to do is, what's going to happen is, if an exception occurs in line number 5, that closing operation will not be done. Or if some other exception comes in line number, say 3, again that will not be closed. Okay, so what happens is, we cannot guarantee that that particular piece of code will be executed. So how can we handle it? By putting that clause in every catch block. Okay, instead what we can actually do is, we can put it in our finally block. Okay, a block called as finally. What finally block will do is, irrespective of whether an exception has occurred or not, the finally block will be executed. Okay, so that kind of cleanup code most of the time we'll be putting in our finally block, so that finally block will be executed in all the cases, even when we are catching that exception, even when some exception has thrown and we are not catching it, even then the finally block will be executed, and then the subsequent operations will be happening. Okay, now if you say, finally, now if you see, exception has come, but again finally block got executed. Now imagine there is no exception at all here. Even then the finally block will be executed, and then now exiting. Okay, so the for any cleanup operations we generally use this finally block, because finally block is guaranteed to execute irrespective of whether there is an exception or whether there is no exception. Okay, like you have opened a file, you want to close the file, put it in the finally block, so that that will be that will be closed for sure. Okay, so that is how we will be able to use the finally block.
Okay.
Okay, and if we see, we can even have finally block without having a catch clause. Okay, and that is also legal. And can you can you try to see what kind of, if Okay, you see the second question in the checkpoint slide. Do you see any problem with that particular piece of code?
Uh, so all the exceptions will be catched by the catch exception itself.
Yes.
It will not go to arithmetic expression.
Yes, yes, that's the thing. Okay, so that's the kind of issue with this exception, catching a directly a parent catch exception at the first time. Okay, the other exceptions will not be caught. Okay, and how do we create exceptions? Okay, so far we have seen all the exceptions that may come out of executing some piece of code, but how do we create exception? We can create exceptions by simply extending the exception class or runtime exception class. Okay? And we have to use throw keyword to throw exception whenever we want to throw it. Okay? So now let's create one exception class and say, let us create a checked exception. To create a checked exception, if you remember the slide, we will have to extend from exception class. Now we created a checked exception. Okay. Now how do we use this exception? We can simply catch checked exception. Okay. Now because we are catching this exception here, it will not be reaching this block. Okay, now this check we have kept an exception, but it says none of this code is throwing the checked exception. Let's say there is a method public static void which whose purpose is simply to throw this exception. Throw, it has to create a new checked object, exception, checked exception, and throw it back. Now what happens? We will have to handle this by throwing. Okay, now what happened is uh, now we have to call this thrower also in this. Now our catch block is satisfied. There is a piece of code that is actually throwing this kind of exception. Now because we have created a checked exception, if we don't use create that clause, the programming the Java program will not be compiled. Either we have to throw it or we have to catch the clause. Okay. Now if we say add throws. Now we run the program. Now we see unresolved compilation problems. Okay, parse exception will not come. Now we got a checked exception. Now if you remember, we got a message right earlier when error and out of bounds exception has come. In that way, what if we want to give our custom message to our exceptions? We can do that. For that, first we have to override another constructor. Okay, for that, let's use this source override or implement methods. We want to override the constructor. So okay, let's do this. So checked exception, and here we will be reading a message, and we don't have to do anything. All we have to do is we have to pass that message value to a super constructor. Okay, this will be calling the constructor in our exception class, whose which is taking one string as a parameter. Okay, now what happens is now it is mandatory that we pass a message. Okay, now what happens over here is when we execute this piece of code, along with our exception, we will also get some custom message over here. Okay, this way we can actually throw exceptions, catch exceptions, whatever we create. Now, as I said, all the unchecked exceptions are extending from some class called as runtime exceptions. Okay, all we have to do is just change that exception to runtime exception, and now it no longer becomes necessary for us to actually throw these checked exceptions. Now, even if we don't throw this, it will not be throwing any exception, even though this thrower is throwing this checked exceptions. Okay, because this is extending from runtime exception, these exceptions will not be checked by the compiler. Okay, so they will be coming when we are executing the program, but it is not mandatory for us to actually create that particular exception. Okay, so this way we will be able to create our own exceptions. We cannot create errors, though we can, but hardly you will ever need to create errors. Okay, so
Okay.
that's how we will be able to create our own exceptions. See, most of the time when we are actually, say, if you are developing this unscrambler program, imagine whenever a user has entered an invalid error, you want to throw an exception instead of simply printing a message. That in that case, we can create a new exception called as incorrect answer exception, and we can use that exception whenever we want. Okay. Sometimes they will be making the program more readable, but use them judiciously. Otherwise, it becomes more and more cumbersome. Okay. So that's how we will be able to use and create exceptions. Do you have any
Okay.
questions, Amos?
No, Buddha.
Okay, so this is about exceptions. So as an
Okay.
exercise, and also I posted a comment, right? Don't upload the class files, upload the Java file so that I can see what's going on over there, what you have written and all. I can see if I can give any comment, etc. I'll do. So try to upload the Java files for those assignments. Okay. So that's it
Okay.
for today. Unless you have any other questions, mm, nothing. So I want you to actually create a new exception whenever user has not given correct answer for our unscrambler game. I want you to extend your application to actually handle that by using an exception instead of printing an error message using sysout. Okay, so try
Okay.
to see if you can create that exception and come up with that, and we'll see tomorrow morning.
Okay.
Okay, yeah. Thank you.
Okay, Buddha.
Thanks, Vince.
Thank you.